Hi everyone. In this problem, we need to find the absolute maximum and minimum of a function within a disk. Okay, so find the absolute maximum and minimum of f of x equals x plus 5y within the domain x squared plus y squared is less than or equal to 1. Well, x squared plus y squared equals 1. We know that's a circle of radius 1. So let's just sketch that here. There's our circle. Now, when I say less than or equal to 1, that includes the interior of the circle. Imagine all circles of radius smaller than 1. It fills in everything that's on the inside. If we want to find the maximum minimum of the function, we first explore whether that could happen on the interior of the disk, inside here. And then we'll explore the boundary. So to see if it can happen on the interior, we look for critical points of the function. So critical points, do these happen? I don't know, maybe we won't even find one. Well, to find those, we look at the gradient of the function and see if it's equal to 0 anywhere. Or undefined. So gradient of f equals 0 or undefined. Is that the case? If so, that's a critical point. Well, let's see, the gradient of f is equal to 1, 5, right? The x derivative, comma, the y derivative. Well, that's certainly defined, and it's certainly not equal to 0 anywhere. So there are no critical points. Okay, so don't worry about finding critical points in the interior. So now what we have to do is we have to explore the boundary, okay, the boundary of our domain. And to do this, what we're going to do is, well, there's a couple ways to do this. One way to do it is to express y in terms of x, and write this as write y as a function of x for the top half of the circle and then bottom half of the circle, and then use that stuff. But I think a more clever way to do this, I think it works a little bit nicer, is to parameterize the boundary. Sometimes you can do this, and in this particular case, it's very easy to parameterize the boundary. The boundary is the unit circle. And we know that there are a couple of very special functions that parameterize the unit circle. It's the sine and cosine functions. In fact, if I specify any angle here on the interior, the point on the circle is just cosine t, comma, sine t. So these trig functions, cosine and sine, parameterize the circle. This is a parameterization of the boundary. Okay, so that's what we're going to do. We're going to parameterize the boundary with this function. You could write it as a vector function, cosine t, sine t. That, off the screen, sorry. So that parameterizes the boundary. So if we want to look at the value of the function on the boundary, we'll just look at the composition of our function with this function. So in other words, we're going to look at f of r of t. And that will give us the values on the boundary. What did we get? Well, x is cosine. So remember what our function was. It was x plus 5y. X is cosine t, y is sine t. So it's going to be cosine t plus 5 sine t. That's our composition function. All right. So I want to find out where this has maximums or minimums. Well, this is a single variable calculus problem, right? Because it's a function of a single variable. So we find critical numbers. So how do we find the critical numbers? We look at where where the derivative of this thing, let's call it a different letter. Let's call this capital F of t. That way I don't have to worry about the composition. I'll just view this as a single f of t function. So I want to know where the derivative of f of t is equal to 0 or undefined. Okay, so let's compute the derivative of f of t. F prime of t is, well, just take the derivatives here. There we go. Is that ever undefined? No, that never happens because these are trig functions. They're defined everywhere. But it could be equal to 0. Well, let's see. If it's equal to 0, what can I do? I can add sine t to both sides. Oops. Divide both sides by cosine t. And sine divided by cosine is, of course, tangent t. So the values of t that are critical numbers satisfy tan t equals 5. Now, we're dealing with a circle, and t represents the angle. Tangent represents the slope of this line. Right? That's what tangent is. It's sine over cosine. It's rise over run. So it's the slope of this line. But if I'm saying the slope of this line is some particular number, in this case 5, look at this line. It intersects the circle not at 1 point, but at 2 points. So keep that in mind. When I say tangent of t equals 5, there's actually 2 values of t here. There's the one that puts me here, and there's also the one that puts me here. So a very common mistake that a beginning student might make is to say that, well, okay, well that means that t is the inverse tangent of 5, or arctan of 5. Same thing as inverse tangent. But you should realize that there are 2 points there. That would give you this one up here. Inverse tangent always gives you the point between negative pi over 2 and pi over 2. But to get this other point, how do we get there? Well, just look at the picture. They are exactly, they call these antipodal points. They're opposite points on the circle. They're related by just adding pi. They're 180 degrees apart, or pi radians apart. So if I just add pi to this angle, I'll get this one. Right? So the other solution here is t equals arctan 5 plus pi. So that's my other solution. There's 2 solutions. Now, we want to know what the absolute minimum value, the minimum and maximum values of our function are, so we need to evaluate our function at these numbers. So, okay, so what I'm going to do is I'm going to plug arctan 5 into this function. So here's the question: what's cosine of arctan 5? Well, there's a trick for doing this. I may as well show you how to do that here. So, what's cosine of arctan of 5? And we'll do sine after this. Well, the trick is to look at a right triangle. Okay. Now, the tangent of an angle has to do with the sides of the triangle. Well, the arctan is the inverse of that. So it takes the sides and gives you back the angle. So if I call this my angle here, call that arctan 5. Well, remember, tangent is opposite over adjacent. So the arctan of opposite over adjacent is the angle. And so that means that 5 must be opposite over adjacent. So I just have to pick lengths here that give me 5 if I take this length and divide by this length. So 5 here and 1 here work. That's the simplest way to do it. And if I put 5 here and 1 here, the Pythagorean theorem tells me that this must be root 26. Okay, so if this angle is arctan 5, and these sides are these lengths, then this must be root 26. That tells me how to compute cosine, because cosine is adjacent over hypotenuse. So this is 1 over root 26. It also tells me how to get sine of arctan of 5, because sine of arctan 5 is opposite over hypotenuse. That's 5 over root 26. So if I go look back at my function here, my function was cosine t plus 5 sine t. Well, cosine of t was 1 over root 26. 5 sine t is 5 times 5 over root 26. So that's 25 plus 1. That's 26 over root 26, that's root 26. So that's when I plug in this value of t. What was my other value of t? It was this plus pi. Well, what does that do to it? Well, there's some... If you just think about the circle, if you add pi to an angle, you just end up negating the coordinates. So what I'm saying here is that sine of theta plus pi is equal to negative sine theta, and cosine of theta plus pi is equal to negative cosine theta, and that's true for any angle. And so in particular, it's true for this one. So if I look at my other value of t, which was arctan 5 plus pi, it's just going to be the negative of this. And the sine of arctan 5 plus pi is the negative of this. All right, so cosine of arctan 5 plus pi is negative this, and sine of arctan 5 plus pi is negative this. So plug those into our expression for f. Well, it's going to be negative 1 over root 26 plus 5 times negative 5 over root 26, which gives us negative 26. Whoa, off the screen. Sorry about that. I'm no YouTube expert. Still working on this. Negative root 26 over root 26, which is negative root 26. Right? So that's the other value for f. So we got two values for f here. We've got positive root 26, negative root 26. So here we have our max, and here we have our min. And just to go back to the picture here, how does this work? Well, the arctan 5 got us, remember arctan always puts you between pi over 2, negative pi over 2 and pi over 2, so that gave us this point. So the arctan of 5, which gave us this, is, we're saying that that maximum occurs right here. And the other value, arctan 5 plus pi, put us here. That's where the value of the function is negative root 26. So the minimum is negative root 26, and the maximum is positive root 26. So there you go.